Hello and welcome to this session. Before starting, please let me thank all the guys behind the Data Platform Summit for organizing this great event, and thanks to Microsoft supporting this kind of events. Who am I? My name is Marco Parenzan. I come from Italy. I am a senior solution architect in BinTech, where we work on many fields, one of which is the IoT space. In Pordenone, I have also a community that is called Innova, where we speak on all around Microsoft, Azure, IoT, .NET, Data Platform. Then I am also an Azure MVP. In this slide, you find the links to some contents I produce, like this session, and also you find my LinkedIn profile that you can use to contact me after this session if you want to continue to this speak about this kind of topics. So, the session is about Power BI streaming data flow and Azure IoT Central. So, let's start. The context of this talk is about you, that you are a data platform guide, because that receive probably a request for a Power BI dashboard with KPIs that have to come from an IoT devices fleet. That means collect data from IoT devices and present some KPI on a Power BI dashboard. This talk is about the fact that you already played with IoT tools in the past, but probably you have found some difficulties because you are used with Power BI to work on something that is almost software as a service, while working with platform as a service can become complicated because of costs, because of skills, because of manageability. And it's difficult to have all the time resources dedicated on this field. So you need some help with some services that can lower the difficulties to approach the IoT. Which is the IoT? Well, I like to classify IoT in two big classes. The first is the industrial IoT, that is something that I work on every day, and I have to say is quite complicated because it has a complex edge scenario. The smart city scenario is more simple, we can say, because it has a short pipeline. You have a sensor, low or nothing edge intelligence, gateway, and then the data immediately to the cloud. So this is what I say that smart scenario are good to describe the IoT and something that is more approachable for you as a data platform guy. To create a more context sample, I can describe a big company that invested in solar energy, installing solar panel in all the plant the company has. And you that work already in the company as a data platform engineer, probably working with Power BI, you receive a request to create a Power BI dashboard to evaluate the savings after solar panel adoption, to make evidence that energy production is good for the company and cost saving. So you need to work with energy and power that you collect from solar panels. So you need to connect to the inverters that measure the energy and power produced and absorbed by the plant and shared to other devices with Modbus, for example, or OPC UA or other protocols. It is not important just to say that Modbus in this smart city story is quite common. And if you focus on inverters, you understand why I say short. Inverter, gateway that communicate with inverter, and send immediately to the cloud. So what I have understood is you as a data platform guy, you need an approach to IoT that is more typical for software as a service, that is typical for Power BI. And if the question is which is the option from IoT in this space, I say Azure IoT Central is an option, is a great option for this scenario. So, if we restart with Azure IoT solution, you will know IoT Hub, Event Hub, Stream Analytics, Cosmos DB, so far and so forth. So, a big bunch of services that you have to put together to build an IoT solution. Well, in this space, Azure IoT Central will cover almost all these services. So IoT Central is end-to-end solution to connect immediately to the devices and then to connect with the application that need to consume the data that are collected by Azure IoT Central. So Azure IoT Central is a fully managed IoT Hub application platform that reduces the burden of building and maintaining IoT solution. So IoT Central is an enabler to get connected to the devices, giving you edge support, support to device connectivity and management, device modeling, and end-to-end security. Then it helps you to stay connected after the first connection, so creating dashboard visualization and insights to manage the immediate lifetime of a device that is working on edge, is working on the field, and also allowing people to interact with this infrastructure, setting user role and permission for the application. And then, after you collected the data, you have to transform that data because you have to send that data to other applications for long-term offline data analytics and other purposes. Azure IoT Central is classified by Microsoft as an application platform as a service. And you see that is almost in the middle between platform as a service and the software as a service. Why say that? Because you have no tenant creation or specific resource allocation like a software as a service, but is also a platform because you can build a solution upon and you have to write some code to make it completely useful. Azure IoT Central is completely based on the Azure IoT platform. In fact, inside IoT Central, you can recognize already some services that you are used to work with as separate services, like IoT Hub, Device Provisioning Service, Azure Stream Analytics, Azure Data Explorer, Azure SQL Database, and Cosmos DB. And then this platform connects on the edge with the devices with specific technology that are external to IoT Central, like Azure IoT Edge or Azure Sphere, and the Azure IoT SDK that is fully compatible between IoT Hub and IoT Central. And then you can export data on your preferred tool, Power BI as the focus of this session, but also Dynamics, Search, Web Application, Logic Apps, or any application you want to work with. Why Azure IoT Central is interesting as not a toy? Because when IoT Central was born 5 years ago, it was considered a toy. Well, again, I already told you, it's fully compliant with the Azure IoT platform. It has an interesting pricing model based on the device. It forces you to think about modeling the devices. It gives you a fast start and you can be connected to the devices in minutes, if something is prepared correctly. And It's also a very interesting tool based on scenario. That means that there is some standards that give you a growth path to grow with your experience on IoT. And it is also extendable with other Azure services. Speaking about scenarios, on Azure IoT Central you have application templates. That is a collection of experience that Microsoft has done with their customers, and they build up some pre-configured solution, and we will see in this session one of them. What is interesting for IoT Central is the integration model. It is completely built on the IoT Hub infrastructure and inherits the integration model of IoT Central, for example, exporting data to Event Hub, to Azure Storage, and to Service Bus. But there are some specific connection of IoT Central that is not inside Azure IoT Hub, which are Webhooks and Data Explorer that are two immediate connected services to IoT Central. Why to work with IoT Hub you need some intermediate service to connect them. You can query data in IoT Central because IoT Central stores data inside him. And then you can also transform data before sending this export. So you don't need to have external process to adapt the data for your endpoint service, but this is inside IoT Central. So let's speaking for a moment for the pricing. IoT Central has a different pricing model compared to IoT Hub. It is based on device, not on message. So if you have 10 devices, you pay for each device, by which you have, for the tier you select, an amount of messages for that month for the device. So you are invited to think as device as a center of cost instead of the number of messages, but you are focused on thinking about the device you connect, and you pay for that, and you pay for that device that send an amount of messages, and you have immediately a tier for the device. For example, 5,000 or 30,000 messages per month per device. Remember one thing, that the fact that IoT Central collect the data, it is a rolling data retention. That means that the data stay there for almost 30 days. So this pricing includes 30 days of storage. After the 30 days, the data is lost. So you need to export data to the resources that I have described in the previous slide to persist the data over the 30 days. So let's set up IoT Central. Okay, let's start creating an application in IoT Central. You can do this in a couple of ways. The first is the most software as a service approach. You go to apps.azure-iotcentral.com URL, and you land on the IoT Central application. You have a toolbar here on the left. You have these buttons that connects you to your application. You need to authenticate, and for our solution you can connect to an Office 365 account to be connected then also for Power BI. So I click on my authentication, and then I arrive in my apps, where I have already my application that I have already created previously. I click on New Application and you see a couple of things. First, you have a custom app that is your blank template for application, where you have an template application where you can write anything you want, or you have templates that are pre-built templates that you can use, but you can also modify. So it's up to you where do you want to start. For example, for our solution, we can use the solar panel monitoring solution that is already created. I click on Create, and then you see that I have application name, and so we can say DPS solar panel monitoring. That is the description of application, the name of application, and you see that that you have built automatically the URL for your application that will have a name as a URL, DPS solar panel monitoring.azure.iotcentral.com. You can choose the tier that you want to adopt for your plan. For example, OK for standard 2, that I remember it contains it handles 30 messages per month for each device, but I didn't told you can add, there is a pricing for more for event messages that exceed this quota. Okay, so to decide this, to build, you need to select a directory for the application that is an Azure AD Active Directory that is again the same of the account that I will use for Power BI. Is not mandatory, but I say this to have an uniform access with the same user. I select a subscription, and then I select a region that is, for example, West Europe, and then you click on Create. The application is provisioning, so you can say this is not software as a service, but is a platform as a service, an application platform as a service. But as you see, and if you remember the schema where you see that you have IoT Hub, device provisioning services, you have a lot of services. You cannot deploy all that services in these few seconds. So this is a provision, is just to configure your application. Dashboard, and by which you can build up generic dashboard that contains so many aspects of the application. And in a simple way, if you have rights, you can collect and manage and change the view and the layout of this dashboard. Just it. That's simple. You can drag and drop, update, and it's simple. Then you have the data export, that allow you to take the data inside your IoT Central and export to another service. I say again something that I have already told. When the data you start collecting today each data stay inside IoT Central for 30 days. So the date tomorrow that starts today will exit at the 31 day from today. The date of tomorrow will stay from tomorrow to 32 days from now. But if you want to collect this data outside IoT Central, because you want to store the same data for months or years, today you have to define a new export. How do you say that? For example, you have a couple of information. You have a destination, where the destination is the service that will collect the data that you need. So for example, you have blob storage, data explorer, event tab, service queue, service topic, and the webhook. I told you that these are the service of IoT Hub. Data Explorer and Webhook are specific for IoT Central. When you have defined a destination, we will do next in the demo, then you have export. On export, you select the kind of data that you want to export, and look at, you can export not only the telemetry, so the message that the device sent, but also the setting properties or the connection status, because the device can connect or disconnect with the internet. The connection is not 24/7 because of any issue. It can connect and disconnect, and you want to monitor that. And so you can export this kind of events. You can also check also if the template, that we'll discuss then, something about the device lifecycle you can export. You can add information to add more info that will be useful from the process that will consume that exported data, and then you select the destination. But we'll do this next in the session. And then you have rules. The rules means that as the data flow inside IoT Central, you can check, for example, if a value that is collected for the last 5 minutes is greater than a threshold, then you can create an alarm. An alarm that means okay, a threshold was reached, and so you need to act in some way. How can I be notified? You can be notified by email. That is more simple. You can invoke a logic apps or a Power Automate. That means you set up a workflow, so you can act in some steps. But typically you implement in a workflow like this, or you can just have a detailed log in Azure Monitor, or you can invoke a generic HTTP webhook to make some specific processing. Now let's talk about devices for Azure IoT Central. If we want to generalize what a device is in Azure IoT Central, we can describe something like that. You have a gateway device that makes 3 major functions inside it. First is a protocol translator, that is the ingestion part that collects the data from the sensors. Any sensor depends on the libraries that you have available, and you can speak with this sensor with Modbus, OPC UA, but also REST API. It is common in the IoT scenario. This protocol translation collects the data with these field protocols, probably to MQTT, and then you handle this data in an internal processing. That this is a general architecture. You can have processing and buffering as big or small as you want, obviously. And then you have your gateway code, that is take the data that you have collected and stored and send it to Azure IoT Central, probably via MQTT protocol. So what you should be aware in Azure IoT Central about device? 3 major things: device type, device description, and device provisioning. Device type we have already described. You can have a gateway, so a processing device that has a multi-stage like the one that we have shown, or just a single process inside the device that read the data and send it to the cloud. It depends on the pattern, if you lead a long pipeline or a structured pipeline with discrete tiers on the edge to be managed, to make processing, to make local inference, to make local storage, and something like that. So think that you have a gateway with, for example, Azure IoT Edge because you want to store the data, you want to run machine learning. Sometimes, as you have just hardware devices that contains a process or retains a compute core inside that can read directly from the internal sensor and send to the cloud. And this is typically for IoT devices. Think this scenario about sensors that are already able to connect it directly to the cloud, so they have intelligence, and so sensor and gateway are fused, are merged into a sound inside one physical device. This is the typical scenario for IoT device. Else you have an explicit gateway that contains probably containers that each of which has a very specific responsibility, but from one side connect to the field and then send data to the cloud. So you use edge gateways because you need to ingest, filter and aggregate locally, you execute command, you configure the device, you receive remote updates, you need to check the health monitoring, and you have a strong enforcement about security. So, after the type of device, you need the device description. That means which are the signals, which are the values, which are the variables that are involved in your data ingestion from IoT. And so you have this kind of screen where you start working with information inside the device, but we will see this on the demo. What is Azure Plug and Play? Well, this IoT Plug and Play is the specification by which you describe the device that we have seen in the previous slide like an application, where IoT Plug Play is the specification that describes how and which information are collected as a device description. Is a specification that Microsoft wants to standardize, also because this description is the same also with Azure Digital Twins. In fact, IoT Plug and Play is based on the digital twin definition language. Then you have also one another topic, that is the device enrollment. You have to think that you don't have only the device that you have to develop and burn the firmware to start, but also you have enrollment. Think the fact that you have panels, solar panels all over the world. You have probably many people that install your solar panels and your gateway on different plants and not use. So you need to manage automatic enrollments for the devices because you need to connect and configure the device specifically on where the device is deployment. For example, you can have geographical requirement, latency requirement for your device. And so you have services in this field. You have device provisioning service that works in this space. In Azure IoT Central, different from IoT Hub, is already integrated inside IoT Central, and you need to manage this immediately. Device enrollment is focused on ID scope that differentiate DPS instances, registration ID that uniquely identifies the device in the DPS, while the device ID identifies the device in the IoT Hub, and then you have the attestation mechanism, that is the way the device authenticate on IoT Central. That can be X509 certificates, TPM challenge, or symmetric key. Now, let's see a demo for setting up device in Azure IoT Central. The first step to manage devices in Azure IoT Central is working with device templates. Different from IoT Hub, where you have just a message with some system properties that are necessary to route the message from device to the cloud, and a payload that is unuseful, we can say, for IoT Hub to be managed. On IoT Central, the payload that you receive from your device is central for Azure IoT Central. You look at this screen, we see that there is already a device template because we are inside an IoT application that is created through a template. Let's look first on what will happen when you click on New. You have a couple of choose, or better, three. You can create two empty device templates from as IoT Edge or IoT device. I told you IoT Edge is a gateway device, like for example an IPC, an industrial PC, or similar to Raspberry Pi, on which you can deploy a bunch of containers that create your pipeline of edge management, edge processing for the events. Or you can have an embedded solution for firmware-based devices that does not need to have a processing pipeline, but just taking the events and sending to the cloud. If I say, for example, IoT device, okay, I can customize, I give it a name, my solar power, my solar panel, sorry. This is not a gateway device, not important in this field. I save it and I click on create. I can import a model because I have an external definition that I can import, or I can go to custom model. I don't enter in this session about components and interfaces. You can look at the documentation of IoT plug and play that in IoT Central, IoT Hub, the digital twin is complete. Just to say that you have added the TDL, that is the JSON representation of a digital twin definition language that represents the IoT plug and play definition, or you can add capabilities that are my information. For example, the power, that is a name, that is a telemetry, has a semantic type of power, telling a power that is a double value, but you can say that a unit is, for example, watt or watt, microwatt, milliwatt, kilowatt hour per year, and something like that. Okay, so I use just to say what you can define. In general, for your position as a data analyst, you will receive a device template ready from the supplier of a device that collects the device, or you have to define a project to define to create a gateway with some code inside, for example, an IoT Central device, an IoT Edge device, which will expose this DTDL. I want to use the device template that is already defined in the template. There is solar power, and you see that we have some generic properties that are useful, for example, for adding information that typically are management information, just to say, write, because you don't need to write on Post-it, on Excel, or a file that you can lose anywhere in your PC, in some server, and so on. You write everything inside IoT Central. So, for example, you can say the installed location, the supplier that has installed that particular panel, cell number, and something like that. If you go in interface, you see effectively the information that are sent by by the device, by the gateway that read this information from the solar panel, for example. For example, the ID panel, that is almost a serial number, power reading, for example, energy reading, that this will be the information that I will use in the demo to show how it works, the temperature, the installation day, and something like that. You see that the distinction is between properties that are information that are triggered mainly from the cloud to the device, or information that stay directly into the cloud, or telemetry that is typically information from the device to the cloud. What is interesting inside the device template is the fact that in the device template, you define also, you automatically have a point of view of the raw value that you receive, and we will see this in the device. I go back. Another interesting thing is that on a device basis, on a device template basis, you can add some view. So this is a dashboard that is specifically for this kind of device. And so when you go on that specific device, you will see exactly this information. The same thing that we have seen before. You can have a global dashboard that looks at multiple devices at the same time, or you can look at data specific for that specific device, for a specific device. This is useful because you can investigate on issue on specific device immediately at minimum cost. What is interesting is the fact that the DTDL is far more interesting here because it's full of information, or mainly if you go to the model and click on here you have the complexity but the richness of this template, because you have all the property and you can build automatic tool to make deployment, code generation, and something like that. So when you go to devices, in devices, the template automatically deploy as one device that has a particular property that is simulated. This is great for demo purposes, for testing purposes. If we go in this device that has its ID, you see already that you have data that are fictional data, obviously in this case, but are good to test all the infrastructure. So you see that these are functional data, but you see that they are already working, so you are receiving data. So you can have line charts, but also you can have last known values. So for example, you see almost which is the value that you read at this time. In raw data, you have the telemetry that is sending, and so this is a great tool to understand what is the real data that you are receiving from the device that will be pushed forward in the IoT Central, and also in the data export. Then you have the commands, so you can send command to the device. This is probably not useful for you as a data scientist. You have the update properties that you have to describe this device. So you understand it's quite powerful because it's a desired experience that can be used, that is simple to use, like Power BI. Okay, so we will use this data that are moving to make our try. We know that are fictional, but it's okay for this demo. Already sending the data, we can now work on Power BI streaming data flow. So what is streaming data flow? It's almost a service like Azure Stream Analytics, now already included directly in Power BI. What is different from the equivalent service in Azure, this is a service that gives you a drag and drop experience without writing any line of code. So this service is useful to make a decision in near real time, as the process that you describe is executed every time a new event is received from IoT Central and processed through the DataFlow. In this way, having a no-code experience, you democratize streaming data because you don't need the knowledge of the SQL code that has to be written in stream analytics. And so this accelerates the time you can obtain some insights that you can reuse inside a dashboard. Creating a DataFlow is quite simple. Streaming DataFlow is part of a workspace inside the Power BI. Like a dataset, like a report, streaming DataFlow is a resource that you create inside a workspace. Due to the nature of streaming data, there is a continuous inflow. That means that is a process that runs continuously until you stop, because if you can stop, you can also start. In fact, this is a feature that is derived from the equivalent Azure Streaming Analytics process. There is a limitation that inside a workspace you can create only one data flow. Only future can say if this will be a real limitation. How do you start a streaming data flow? Well, a streaming data flow starts with receiving the data from IoT Central. Currently, IoT Central streaming data flow does not connect directly to IoT Central. You need an event hub. This has to be detailed. There is no direct integration between IoT Central and Power BI, the streaming data flow. Power BI streaming data flow can connect to Event Hub and IoT Hub. And as we have already told, inside IoT Central there is an IoT Hub instance or more than one, but this is not reachable, as the management of the device and the resources is completely internal through IoT Central. So, to access to the event in a streaming form, you need an explicit event hub, not in this case IoT Hub, as you don't need to manage the device another time. So, to process event with streaming data flow, you need to create an event hub, route events to an event hub, and then you can use that event hub as a source for the streaming data flow. Then you can start processing events, and you can do with some operational blocks that you can use. For example, you can use filtering, because for your specific data flow you want to consider only events that satisfy some condition. For example, you need events that has a particular property set to some event, or you use the particular data flow only for values that are greater or lower, for example, to a threshold value. Then you can perform projection, because as the event that you receive from IoT Central contains all the variables that you can expose from IoT Central, then you want to consider only just some values. For example, in our scenario, for our particular KPI, we are interested only on power and energy. So you can select only the events, only the properties that you really require. And this allows you to make focus on that, and with the impact on Power BI, you minimize data that you will insert into a Power BI dataset because you store only the fields that you require. Then, for example, and that is typical for this kind of operation, is the group by operator. The group by operator allows you to group events in a window, because as you receive events that have some frequency, for example, you have a power lecture or an energy lecture for every, I don't know, 30 seconds, 5 seconds, 1 minute, but for your KPI, for example, you need a grouping operation only on a bigger interval, let's say 5 minutes, 10 minutes, as you wish. So group by allow you to select the field that groups the events, for example, the time, and you can select the events. But how do you group a window, a set of events of that size through the time? For example, you have windowing. So, for example, you can use thumbling window. That means that you group by not overlapping windows. So, for example, having the average of the power consumed every 5 minutes. But, for example, you can require having overlapping windows. So, for example, having the events grouped by 5 minutes but repeated every minutes, for example. Or, for our scenario, you can have sliding window. That means the windows are calculated every time an event exits from the window and a new event comes in. There are many different scenarios that are useful. Where do you put the data that you calculate as an aggregation, for example, from this process? At the time, the only output is a table that is collected inside a data set inside the Power BI. So you specify the name and the data are written continuously in that time. So, as you have defined the process that can be complicated as you wish, then you have defined the process that you can start. We have already told on a stream analytic basis the process of processing the data can be started and can be stopped. So, from the console of the workspace in Power BI, you can start and stop the process. Obviously, when the process is started, you cannot update the process. You have to stop to change the structure of the data flow. So, as you have your streaming data flow up and running, you can go on your report, typically with Power BI desktop, and you can start building your report. The first thing you have to do, as all the reports in the Power BI, you need to select a data source, and you select from Get Data the data flow connection inside the Power Platform group. In this way, you start collecting data not inside the workflow but inside the data set, and you have two locations where to do. You have hot and cold table. So hot is where you can store data to show real-time visuals, and is useful again to show real-time visuals that can be updated with high frequency, while you have a cold storage where you can where you can analyze the data for more long time. In fact, it is stored with the support of blobs if necessary. To allow the visual be updated continuously, you have to set the storage mode as a direct query, so you can obtain data directly from the streaming data flow. We have to say before looking how it works some limitation. The first that we have to be honest, we don't have to say that is a limitation, is the fact that streaming data flow are available only with Power BI premium subscription, either a capacity or a premium per user. We can always discuss about the cost, but we can say that the power of this feature is valuable for how much you have to pay for license, like a premium per users. A real limitation, but we have to understand if practically a limitation, is the fact that you can build only one data stream per workspace. As you can also you can write multiple tables inside a single data stream. And another limitation, again, we have to say if this is really a limitation, is that you need at least in Power BI embedded a tier A3 to allow streaming data flow. So let's set up a Power BI data flow. Now let's proceed creating the Power BI dashboard with streaming data flow inside. Before proceeding it, we have to complete the IoT Central configuration, because if you remember, if we want to connect the streaming data flow, we need an event hub where we can route the events from IoT Central outside it. So first we need to create an event hub resource. So we go to the marketplace in Azure, we select Event Hub, I create Event Hubs, create, I set the same name, DPS 2022, West Europe, pricing tier standard, create, I don't change any other property for that. Okay, go to resource, and here I have my event hub namespace. So I need to create the specific event hub that I call solar panels. Then I create a shared access policy that is IoT Central, which I give send rights. Okay, I click on IoT Central, I click on the connection string, and I have it. With this information, I can go to data export, and I say a new destination, event hubs, connection string. I copy the connection string, and I say solar panels. Just to check, solar panels. That's correct. I say solar panels as name, and so I have created the destination. Now I create the export, that is solar panels. I say the telemetry. Okay, so I have no condition. Okay, I say the destination. The destination are solar panels. What is interesting, I say, device template equals, and I say solar panel. That's correct. I cancel this, no transformation. I create, save. And this way, I have my data export that is not yet started, destination waiting. Now that we start working, we can start creating this, you see that is starting. I get back here to Event tab and I click again on Shared Access Policy and I add another policy that will be Power BI. That is listen, because you have to receive events in Event tab. I click on Create. Okay, I click on Power BI and I click on Connection String. Great. So we can go on Power BI. We have our workspaces. I can create my new workspace. I create DPS 2022. Again, I told you I am a premium per user license because this is a requirement to use this feature. Okay, I have created my workspace and now I can create my streaming data flow. Okay, solar panels. Okay, I click on Create. And here you have your editor. Okay, blank canvas, you see that you have inputs, transformation and output. Now I have to go to the event tab, to the specific event tab, create a shared access policy, and I create hub and I say Power BI. I create listen because I need to receive the event and I click on receive. Why I go to the event tab while I was on the root namespace for the event? Because I can specify from IoT Hub, from IoT Center, sorry, the event tab where to route the events. In Power BI, for Power BI for Event Tab, I need to select the specific Event Tab where to retrieve the data. So I need a connection string that contains directly the Event Tab. So I have my connection string and I can go to Power BI. Now in our Streaming Data Flow editor, we click on Event Tab and we have our Event Tab that you can configure. You copy the connection string, you have to set the consumer group, that is default in this, because it's the default for these settings, is a good practice to create a consumer group for each process consumer, but for this demo it's okay, and we click on Connect. As the process uses to refresh data, it's better to connect immediately the output table so setting the solar panels as a name for the output table to have the information that is okay and that can start setting up correctly everything. So now that you have set up this, we can add, for example, you see that you have a solar panel. If I go auto detect, will looking for the data, and you see that he has looked inside the event tab and has found messages containing this information that correspond to the export that we have seen before. Now what we can do, we can delete this connection, we can make space between these blocks, and we can add, for example, manage fields. Manage fields, and we connect again because the editor can stream correctly, and on select fields we can say, okay, add, for example, VNQ time. Okay, I can select inside the telemetry, for example, the energy amount, and we can add the power amount. That can be interesting for our demo. That's okay. So to make it more interesting, we can add the group by operator. That means add again this. So group by, we can select the aggregation. So for example, we can calculate the average of the power, and you see that we have a tumbling window that can aggregate over time of in a window of 5 seconds, 10 seconds, just to make some samples. Okay, or we can say 1 minute because the demo is going quite slow generating the events. Okay, and we can and add, then I can select the sum of the energy again in the same thumbnail window, and I click on save. That's okay. During the editing phase, you see that if you look at the event tab, the data flow is stopped. You see that you are looking inside the event tab, and you see that you have the original messages that are coming from Azure IoT Central. So I can click on save. I can go to my workspace. You see that I have solar panels and I have my button that allow me to start streaming the data flow. Okay, now we can go on our Power BI desktop where we have already our project as DPS 2022. The first thing to do is to get data, and we go on more to look all the connection that we can use. Okay, we go on Power Platform. You see that you have data flow. I click on Connect. Okay, and you see that you have workspaces. I refresh my authentication. I click on Connect. Okay, I connect to DPS 2022 solar panels. And as I told you before, I connect to the hot streaming data. And I say load. I can transform, but it is not the case for just this demo. But then you can work as a Power BI developer as usual. I select direct query. Okay. Okay, and here you see that I have my data table with the data that I need. So what I can do? First, we can go to page refresh, we can go to on and set I refresh every 30 seconds just to make the update. Okay, in building visual I can use my line chart. Okay, I can drag and drop. I'm not good at with that, but it's okay. I add NQ time on the x-axis. I add the average and the sum as y-axis. Okay, and that's it. Now the visual will collect data and start drawing some lines. That's fine. I rename the page as solar panels. Okay, and I click on publish. Okay, I choose my destination, my workspace specific. I click on select and it's publishing. Got it. Okay, so if I go to my Power BI, I refresh the page so we can look at the report and the dataset. So if I look here at the report, we can see the same that we have already done. Great. So what if we click on... So what we can do now? We can file, embed the report, and I can include this dashboard in a website or portal. Okay, click on website, and this is the link. I click and I copy. What can I do now? I can go back to Azure IoT Central. I can go on dashboard. And what I can do, I can go on dashboard catalog. I can create a new dashboard and I say analytics, or we can say solar panels analytics. I can click on create. Okay, I can go to edit. I can click on line chart. Okay, I click on edit. I can select the device group, for example, solar panel, all the devices. I can add as capabilities to show the energy reading and I can add the power reading, and this is an update. So here you see the live data from the devices. Then I can go here. You see that there is a tile that is an external content. Okay, I can click on this. Oh, sorry, I reduce just because we are in a demo. I drop this, and you see that this content is a web page. So what if we go in it, see that we have a source, and we can paste the URL that we have copied on Power BI, and we can say write Power BI. I click on Update, and you see that inside the external content there is a Power BI dashboard. And you see that Power BI dashboard is imported correctly. I click on Save, and you see that we have our dashboard. So this is great because as we have already in IoT Central many different tools, you can add more information, adding external web application that can be included as external content. And you see that you have your tool in Power BI, but also, for example, Azure Data Explorer or other tools that allow you to make the same thing. So we are at the end of this session. We have our dashboard up and running, so we can make our final consideration. Azure IoT Central is a mature solution to solve several IoT scenarios. Again, Azure IoT Central has started with a few years ago with consideration that it was a toy. IoT Central is now a mature tool that can effectively be approached as a SaaS solution to minimize the use of our external services. Microsoft is investing a lot on this platform, and we will see probably many new features and integration also with Power BI. So to minimize the effort more and more over time, like what we have seen this. And again, Power BI with this abstraction of streaming data show how Power BI is a powerful tool that more and more over also Azure IoT Central, on which Microsoft is investing a lot of effort to make it a platform for many solutions, and now also useful for several IoT scenarios. So this is the end. Thank you for attending this session. I say thank you again to the organizer of this great event. Bye.